Hi, everyone. Thanks for joining this session presented by Sergey Morozov, President of DATADVANCE. So please let me introduce Sergey in more details. Sergey has received a PhD in physics and mathematics with specialization in theoretical physics from Institute of Physics and Technology. He was awarded the Telegdi Award and the Leonard Euler Award of the Humboldt University in Berlin. He's an author of more than 30 papers in referred journals and proceedings, and he has consulted with various companies and international organizations. Today, the title of his presentation is Low-Code Platform to Create, Manage, and Deploy Digital Twins. Sergey, the floor is yours.
Thank you, Laurent, for this introduction. Indeed, I will talk about digital twins today and how to create, deploy, and manage them. We had really great introduction to the subject by Don from Sim Data, so it will make the whole presentation way easier. So my goal today is to answer basically two questions. How P7 software enable digital twins strategy, and how collaborative low-code platform is essential to scale this strategy. And implicitly, I will highlight a few main differences between P7 desktop application and pSevenEnterprise, our cloud-native solution. So let's start. The first thing, let me remind you what is a digital twin, although Sim Data already did that really well. So digital twin is a virtual representation of a physical asset or collection of physical assets, what exploits information flow to or from the associated physical assets. So the virtual representation is essentially a set of various interconnected models which you normally start to build even at design stage of your product or asset lifecycle. And I intentionally do not refer to the types of those models. They could be just 1D models, 0D models, 3D CFD models, or just machine learning models. This really doesn't matter. So it's just interconnected set of models, which at design stage could be also used to predict product behavior, predict product properties, optimize product properties, and so on and so forth. And at this stage, and this is really very important, they are not yet connected to the physical asset. But then when you go to operations, you're kind of instantiate those models to become connected to the physical asset. And meanwhile, you can reduce those models or modify those models to fit the operating requirements of the asset. So for example, if you're working in real time, your models have to be fast and at the same time accurate. And Joseph in the previous talk introduced the concept of surrogate models quite well. It's also important that the information you collected from the asset in operations can be used to improve your models at design stage, and actually for this you close the loop, and then you can repeat, you update the model, and then you bring the model to production, to operations, and so on and so forth. So all in all, one needs to build those models, and actually not only build once, but to continuously actualize and deploy and manage those models. Or in real life, it's actually not just one model, it's a large set of models. And of course, for this, we need special software to solve this set of tasks. And P7 is one of the large set of tools needed for this. Let me briefly introduce the P7 product line. So we started with P7 Core back in the days, back in 2010, and this is the set of algorithms. This is the Python library for machine learning and optimization, mostly for software developers, for advanced engineers and data scientists. Then we introduced P7, our desktop application, which is a kind of heavy client for our P7 Core library. And Then just 2 years ago, we introduced pSevenEnterprise, our web-based open platform for large enterprises. And today I will mostly speak about pSevenEnterprise, but as I introduced in the very beginning, I will try to answer the question, what is the difference between P7 Desktop and pSevenEnterprise? So the first bit of the answer is shown here. We can have 2 stages of the design cycle and the users. Here, and P7 desktop application is mostly valuable at the design stage of the product lifecycle. Is mostly used by superheroes, for example, to solve multidisciplinary analysis and design optimization problems. And by superheroes, I mean a group of people who have great knowledge of the product, how they are designed and so on, of the models, and also they have great knowledge about automation, programming, mathematical methods, so really PhDs and superheroes. And they mostly work in R&D departments of large high-tech companies. But also P7 can be used by power users who are less experienced, still have great understanding of the product and simulation tools. P7 desktop application is also valuable in operations, but honestly, not a lot. You can still build your ML models. You can use them through exporting to some neutral formats. But there is really one main challenge with this desktop application is that it's not really collaborative, so it does not enable collaboration. And this is really key for building interconnected set of models for digital twins. And pSevenEnterprise actually solves this problem. So at design stage, you have more or less the same set of tools for superheroes and power users to solve their specific problems. But you also have much more to capture, deploy, and deliver those automated methods to domain experts. And that's why you see here those domain experts, really big population of users. And all this is available on a unified collaborative low-code platform. So they all can collaborate. So superheroes can build stuff for power users, and power users can build stuff for domain experts. And this is even more important and even more true for operations stage of the product lifecycle. pSevenEnterprise has a really powerful set of tools for model deployment and model management. And this enables power users and domain experts and even data analysts and even operators to efficiently use those models as part of the digital twins. And again, all this is available on a unified collaborative low-code platform. Let's quickly introduce P7. It has 3 main capabilities. First thing is about workflow automation and workflow orchestration. This allows to capture and automate simulation and data processing. It allows to integrate in-house and third-party tools and perform multidisciplinary analysis. P7 also has very powerful design optimization capabilities to solve multidisciplinary optimization problems, assess robustness and reliability, and make smart decisions on operation decisions. And a final bit is machine learning. We have also a powerful set of tools to build models, as Joseph mentioned in the previous talk, to build surrogate models. You can use those tools to define model parameters, to validate and explore data-driven models, and so on and so forth. And you actually don't need to be a super expert to use this stuff. That's why in the previous slide I mentioned that it's also for power users. We have the technique called smart selection, which is automatic selection of the most efficient method for a given problem. Speaking about automation, we have a full-fledged functionality for process capturing. And the process could be either simulation process or data analytics process or optimization process. We have maybe one of the most powerful workflow engine on the market. This is actually kind of visual programming environment with intuitive and visual definition of the complex processes. So you can implement various nested loops. You can implement logic by embedding logic operations. Those workflows can be executed locally because we are talking here about the desktop application. Again, P7 is a desktop application, but also P7 has a limited support for remote execution in a, let's say, single user mode. It has, though, automatic parallelization capabilities, error handling, caching, and data reuse, really very sophisticated and powerful workflow engine. P7 also has a rich built-in library of blocks, these blocks to build the process. It has native blocks for all major CD and CE software tools, and it has blocks which we call generic integration blocks for the most of other CD, CE, third-party, and in-house tools. And this stuff works through automation of your generation of text files, execution of your solvers, and parsing of your text files. Speaking about methods, as I said, smart selection is really a very important feature of P7. It allows to use the product even by not great mathematical experts. So you define the problem, you specify some hints about your problem, and then smart selection selects the most appropriate method for your problem. We have internally a lot of methods. So it's not just one method which works in all circumstances. No, it's really a lot of methods, and P7 and smart selection is a kind of meta heuristics which selects the most appropriate method for a given problem. And it works for predictive modeling, optimization, design of experiments, and uncertainty quantification. In the predictive modeling world or machine learning world, it's sometimes called AutoML. A few words about methods. We have most of what Joseph mentioned in his talk. We have really large set of capabilities for design optimization, for multidisciplinary design optimization. We can solve with P7 single and multi-objective problems, robust optimization problems. We do support large dimensional problems. We do support heavy simulation solvers. We support continuous and discrete variables, multi-model, nonlinear, noisy functions, and so on and so forth. So all those peculiarities of working with large scale simulation models. And again, on top of this, we have the smart selection that chooses the optimization algorithms automatically and adaptively. I'm not going to go into too much details here. We presented this really a lot of times already. A few more words about predictive modeling. Nowadays, it's more or less a commodity. We started this more than 10 years ago. We have our own library of machine learning techniques. But on top of this, we have really easy to use visual tools to build and validate models just in a few clicks. So you can build fast and robust predictive models with automatic selection of the technique. Again, this is what's sometimes called AutoML. We do have hyperparameter optimization. We do have meta learning. We just don't have the neural network architecture selection. You can also validate your model, test against the reference data, and compare models to find the best approximation quality with the model validator, again, visually. You can explore the model. You create it visually with Model Explorer. And you can export to neutral formats, including C, source, or Excel, or FMU, and these exported models can then be used in operations embedded into, let's say, third-party platforms. In addition to visual tools, you can, of course, automate the whole process of model building, model validation, model export, and so on using our workflow engine. We will see some nice examples how these capabilities are used to solve real-life industrial problems. But now let's switch the gear and now let's go to pSevenEnterprise. And I will try to compare it with P7 Desktop just in the coming slides. So pSevenEnterprise has three main, let's say, blocks. pSevenEnterprise Studio, which is kind of P7 Desktop in terms of capabilities. It has pSevenEnterprise Apps Hub. We will talk about this later. And we have pSevenEnterprise Analyze, which is still in beta stage. But it allows you to do more or less what you can do with P7 Desktop in terms of analysis and post-processing of your data. Now let's compare with P7 Desktop. P7 Desktop has these three major blocks. In pSevenEnterprise, you also have same capabilities, but these capabilities are just 2 blocks among 9 other capabilities which are available in pSevenEnterprise. So in addition to workflow automation, you have platform native library of blocks. You have capabilities to create your own blocks, and this is really one of the key features I will focus on later on. You have a very powerful capability to create and publish your workflows as applications and services on the platform. You have the storage of those apps and services and the management capabilities for those apps and services in the part which is called Apps Hub. All things are interconnected inside P7, but also P7 can be connected to external third-party tools through a rich set of APIs. Machine learning is the next one. I briefly introduced, so you more or less have the same stuff as in P7. Very important thing, pSevenEnterprise is a multi-user collaborative environment with cloud-native scaling. And I will now dive into those features. As I said, workflow automation is very similar in pSevenEnterprise, is very similar to what you can get in P7 Desktop, but with several very important additions, let's say. pSevenEnterprise allows you to execute your workflows in a multi-user distributed heterogeneous environment. So it's not anymore a single user, single run on a single machine. I will come to that later. pSevenEnterprise is a true collaboration environment, and this is so very important. So you can build all those stuff collaboratively. And again, all these features are supplemented with the rich APIs. Let's speak about execution. This is really very important and distinctive feature of pSevenEnterprise. As I said, you can execute workflows in a multi-user distributed heterogeneous environment, meaning Linux and Windows machines under the hood interchangeably. And in pSevenEnterprise, we have special means to manage those computational resources. What does it mean? Let's imagine you have several users on the platform, which is really possible situation. You will see this in the coming presentations by others. And those users can run many workflows simultaneously. Those workflows are kind of decomposed into blocks, and each block can be executed on a dedicated resource which is managed by the platform. And then those people can see the results of the execution of their dashboards. Again, it's not anymore single user, single run, single resource. It's multiple users running multiple of workflows on the different resources in the distributed environment. On top of that, some of your workflows can be executed as a service, meaning it runs, let's say, in an endless loop, and it runs on the same resource pool. Those workflows very soon can be executed on schedule and based on some triggers. We will mention this during this day. Speaking about machine learning and optimization, all our P7 core algorithms are available in pSevenEnterprise either through Python or through dedicated blocks. We introduced a design space exploration block to pSevenEnterprise this year. Our ML blocks from P7 desktop application are coming really soon. But you can use your favorite Python ML optimization libraries, and not only Python libraries, whatever you like actually. pSevenEnterprise is an open environment. You are not blocked anymore with our own P7 core algorithms. You can use whatever you like. Through Python or as I said, through other languages. Another distinctive feature of pSevenEnterprise is cloud-native scaling. Most people associate cloud with something like software as a service and something managed by the vendor. This is not the case for us. We are using this word cloud-native just to associate with other beautiful features of the cloud, like collaboration, like sharing, and so on and so forth. So essentially, it's a client-server application which you can install on your IT environment, IT infrastructure, on premises, on bare metal, plus some additional stuff like Kubernetes, or you can deploy it on private cloud like AWS, DigitalOcean, Azure, Google Cloud. The important thing is that you manage your deployment, your installation. We don't have access to it, so it's not really software as a service, not at all. And through this, you have really a lot of, let's say, cloud-native features like browser access. You just need the browser to use the platform. You can use it on any device. You're not locked to your laptop or your workstation. You can even use it using your tablet. This year, we introduced a lot of, let's say, IT security stuff like single sign-on, Active Directory without integration through Keycloak. We will present this later on. Now, let's go to maybe the most important thing of pSevenEnterprise is collaboration. Remember that digital twin is an interconnected set of models. And actually a hierarchical set of models. So we can start with this. This is just a picture, visual picture, let's say, static picture. This is a representation of some real system. You have this top level, let's say, master model, and then you can decompose it to subsystems, and then subsystems to parts, and so on and so forth. And in real life, this stuff is managed by different people, different departments, and thus unique collaboration. Let's say this master model is managed by the chief designer or chief architect. And in pSevenEnterprise, this is represented by the master workflow. But then you have sub-workflows. For example, this one is managed by thermodynamics department, and this one by compressor department, and this one by combustion chamber department, and this is by turbine department. And all those guys, they have to collaborate. So you see, they have to collaborate not on paper, but on real executable workflow. So they need to be able to build these elementary blocks, build these workflows, and embed those workflows into master workflows. And pSevenEnterprise allows you to do this at different levels. At team level, at department level, at enterprise level, and even at external enterprise level. And of course, remember, different types of users can interact. Superheroes, power users, and domain experts. I will show you how. At the lowest level, let's say, you can just work with your workflows in the browser. At the team level, you can collaborate with your partner like you do in Google Docs. So you can simultaneously co-author your workflow to build just one workflow. And you can, of course, share those workflows with your teammate or with your department or even enterprise. Interesting thing, as usual for the cloud, you don't need to move files. You keep your files in pSevenEnterprise in your private or shared workspace. You can drag and drop the files from the local machine here, and then they will be managed by the platform. On the platform, you can actually, let's say, superheroes can develop and share user-defined custom blocks, and they can also build the library of those blocks. Why is it important? In many industrial environments, a lot of in-house software tools exist, so there is a need to wrap them and embed them into the workflows. And the first step people normally do is they create their blocks for this, like I presented on this slide. So this is the block for one specific tool which is used in this specific workflow. Let's go back. And then the superheroes, they create blocks. They give those blocks through the workflow library, or common library for the whole enterprise, to power users, and power users can then create workflows at the team level or department level, and then they can share those workflows with others to build the master workflow, as I showed before. And this is just an example of the workflow library which is built for that specific turbo machinery case. And for this, by the way, you can standardize tools across enterprise, because you create the block once and you put this block to the library and you use it. From the day one, we actually built pSevenEnterprise with version control in mind. All our workflows are actually managed by internal Git. This year, or maybe beginning of next year, we will make this available and accessible in the UI through versions and snapshots. And also, by the end of this year, we will release a new nice feature, which we call workflow by reference. So you will be able to reuse the whole workflow as part of your master workflow. Anton Saratov will show today some already working examples of this. And the next level of collaboration is through the PLM or SPDM platform, and this is enabled by the open architecture of pSevenEnterprise and through our APIs. I will first focus on this, and then we'll go to the very interesting stuff which is called Apps Hub. There you can actually publish your fully automated workflows as ready-to-use applications, engineering applications, or as services, and which could be as well reused as building blocks in workflows. Let me skip this just to save time. What about extending those SPDM platforms? Through APIs, you can connect pSevenEnterprise to more or less any PLM SPDM platform like Teamcenter, RS Innovator, Sim Manager, Sim Data Manager. Of course, those tools also have to have APIs, but most of them they do have APIs. This is an example how it works with RS Innovator, and what's the border between SPDM and PIDO, which will be explained in more details today by Mark Norris and our people. So on our side or on SPDM side, you do task management, let's say task and approval workflow and process lifecycle and artifact management. And on pSevenEnterprise side, you do the simulation workflow automation and orchestration. So let's read it from the left. You embed all this zoo of tools, commercial tools and in-house tools into P7 using our low-code approach. We have all connectors for this. And then you embed just once the pSevenEnterprise into your SPDM platform. And then users of the platform can execute processes just in a few clicks, either fully in batch mode or interactively with the UI available for the workflow, or even custom UI created for a given workflow. And this is precisely about Apps Hub. So you can create your workflow as a power user or as a superhero, and you can package this workflow just in a few clicks and publish it as an engineering application to the place which is called Apps Hub. And then this workflow can be executed in using either automatically generated user interface, a set of forms. There you just need to provide the inputs for this workflow, and there you will get the results, either numbers or tables, files, whatever, doesn't matter. Or you can, as a developer of this workflow, you can even create a custom user interface on top of this workflow, fully interactive with some, whatever you like actually. And you can create this with any framework you like. And this is the way we help to democratize these automated tools. We help superheroes and power users to share their knowledge, their automated processes with domain experts. And that's why, remember in the beginning, I said that with pSevenEnterprise, you can approach much larger engineering population of your company. At the same time, superheroes and power users can do this way faster compared to previous approaches, traditional approaches. This is one of the examples. You have this simulation workflows, actually set of simulation workflows. And on top of this, you can build some web-based engineering application. This one is used for automatic calculation of some radial clearances in the turbo machinery industry. So again, you capture the multidisciplinary analysis process using low-code approach. You create the custom UI, which is not super difficult to do. And for this, you get up to 4 times productivity gain compared to traditional approaches. And then through this, you enable massive simulation campaigns by domain experts. So you don't need any more superheroes or power users to run those campaigns. Those domain experts can use just this UI to run the whole campaign. And these engineering applications, they live in the place called Apps Hub. See, you can have different places. It's like App Store, your corporate App Store of engineering applications, although you still don't need to charge your engineers to pay to use those apps. But in addition to engineering applications, you can actually publish models as services to Apps Hub. And this is actually the link to the operations of your asset. And here we have different compressors, compressor models sitting in the Apps Hub and running simultaneously in real time. So now let's go to this in operations stage. Again, digital twin is something which is connected to the real asset. Here is the real asset. From the real asset, you have the data stream, telemetry stream, which you can directly send to dashboards, to some BI tools, whatever. But we want to do something smarter. We send this data stream to a set of models, actually to the digital twin, which is used to generate certain predictions about the behavior of your asset. And then you bring those predictions to some dashboards, and operators, they decide what to do with this and close the loop. They can send comments to stop the equipment, or they can just tune the parameters of the process to optimize the efficiency of the process and so on. The key for us here is that we need fast and accurate models for the given purpose, because sometimes it should be real time, sometimes it should be executed just once a day or once a week and so on. And we need the tools to build those models and deploy those models at scale, because it's actually not just one piece of equipment. It could be hundreds of assets to be managed by more or less one or a set of models, but connected to different data streams. So let's talk a little bit about these fast and accurate models. And this actually brings us to the notion of hybrid digital twins. It's actually a mix of simulation and machine learning. With simulation models, sometimes you can use them directly if they are fast enough, or you can use them as is, or you can export them to FMU, FMI and use in your simulation tools. Those simulation models, of course, have to be adapted to the real operational data, let's say calibrated. Sometimes ML models can be embedded into simulation models. And then the simulation models can be used to generate synthetic data, to generate ML model using that data set, and then you will use ML model instead of your simulation model. And of course, this has to be automated because data changes, you need to retrain your models, rebuild your models, and you need to have some set of automated processes for this, also for deployment and so on and so forth. This is the process in more details. You have the data coming from the equipment, telemetry data. You can use this data directly to build the model, the machine learning model, with any tools, Gaussian processes, deep nets, doesn't matter. But you can also use this data to calibrate your simulation tools which in turn can be used to generate synthetic data and complement your telemetry data, which can be again used to build your ML models. At the same time, the telemetry data can be used, as I said, to build some ML models to be embedded into simulation tools to replace, for example, something which is complex to simulate. Simulation tools, as I said, also can be used directly within your hybrid model if they are fast and accurate enough. So all in all, you have hybrid simulation ML model which is fit for purpose. And with this, you can build certain applications like planning and scheduling, like real-time process optimization, like fast and reliable prediction of resources consumed by your asset, or to adaptively design and experiment the optimal process parameters. Why do we need low code for this? Because in real life, you have a lot of models. The models have to be rebuilt, revalidated, redeployed, and so on and so forth. And with deep code or with pure programming, sometimes it's very difficult. So this is just one example how to build the model. And, this is the screenshot from P7. You have the data loading, data processing, data checks, model training, the model itself, and then you plot something to test the model. And here you utilize a set of visual tools to extract data and to train models and so on. Same here for validation. You can generate some charts that you can export from this workflow to assess the model and to decide whether you want to deploy it or not. Deployment, you can deploy the model as a service, actually the whole workflow as a service, and we have special blocks for this, for deployment, to attach it to certain data streams. And then in the loop, you do data checks, model execution, and writing the data to the database. And of course, then you have many of those models. You need some tools to manage those models. And AppsHub is the first step towards this. This year, we will release the stuff called Run Center to manage those models more efficiently. The key benefits of low code is that you can significantly improve the productivity of your engineers to build and deploy those processes. And you can reduce time to bring this hybrid simulation ML models to production. Of course, pSevenEnterprise is not the only tool needed to operate digital twins in real-life environment. So it's a huge, sophisticated infrastructure. So here you have data sources, real equipment, instrumented with some sensors. You have data acquisition processes. You do the data integration. You store the data in your virtual data lake. You need something for data reporting. In most of the cases, it's beneficial to have the object model of your asset or set of assets. On top of that, you need to have data governance, development, security, and operations, and actually many more. But as soon as you have your data in certain location accessible through APIs, you can apply pSevenEnterprise, and you can think about pSevenEnterprise here as a simulation ML studio to process the models exactly as I presented before. You can do data processing, exploratory data analysis, feature engineering, model development using our algorithms or external algorithms. You can apply AutoML and so on and so forth. And finally, you can build applications empowered with the models created with pSevenEnterprise, either for operational predictive maintenance or production forecasting, or things like digital oil fields. And just to give you some visual ideas, data reporting, for example, you can attach your data streams to this kind of dashboards to see your equipment in real life. This is not part of pSeven, but this is just what you can do with data. This is pSevenEnterprise. This is there you build models and deploy models. And this is the applications you can build, like the predictive maintenance application. There you have the forecasts, then your equipment is going to fail, and so on and so forth. Through a set of APIs, P7 can be connected to either in-house IoT platforms or third-party commercial tools like Cifra or Splunk. And this is just to give you an idea of what can be done in this approach. We completely rebuilt one of our old use cases using this new pSevenEnterprise architecture. This is about the prediction of the failures of some gas turbines. This is the analysis of the historical data. The turbine was finally broken, a lot of damages. But if this predictive maintenance stuff was there, it could save something like 10 millions of euro. And this is actually the process. You have actually sensors. You had sensors on that machine, and you had readings from those sensors. But it's really difficult to understand what's going on here in this mess, and that's why you need this machine learning to process this data and to present just one value, let's say, which would be used as a prediction if something will happen with the machine. And this is the type of the parameter you can build out of all this raw data using pSevenEnterprise approach. And you can see, just looking at this predictor, let's say, you have the early precursor of failure, the deviation from the normal state, and then it's the systematic deviation from the normal state, and then failure. Essentially, at this moment, this asset could be fully stopped, and this disaster could be avoided. Again, pSevenEnterprise is not the only tool needed to build this, but pSevenEnterprise is the enabler to build it. It's one block in the whole stack, and it allows you to bring the models from design stage up to operations. And the benefits are threefold, if you want. So first of all, pSevenEnterprise, compared to traditional approaches with deep code approaches, really allows you to reduce time and to improve productivity of your people, to reduce rework. pSevenEnterprise, for all those collaboration and low-code capabilities, allows to perform automation at scale, either at design stage or at operations. And last but not the least, with this formalization of the processes, automation of your processes, deployment of the processes from R&D departments, from superheroes to field engineers to domain experts, you really enable knowledge capture of your enterprise and transfer of the knowledge across the enterprise. And I think this is one of the most important aspects of deploying pSevenEnterprise across the whole enterprise. Please don't forget this. So that's it. I hope I convinced you that pSevenEnterprise is the right building block for your digital twin strategy. I'm pretty sure you still have questions. Please proceed. And if you want to try the software, please don't hesitate. Paul, I don't hear you. Paul, I don't hear you. Maybe it's something wrong with my setup, but I don't hear you, Paul.
Do you hear me?
Yes, now I can hear you.
So, good morning, everyone. I'm Paul Maury, one of the account manager in Toulouse. I'm very glad to animate this Q&A session. Thanks a lot, Sergey, for this presentation. I'm going to switch straight to the first question. So if my CAD tool does not have a dedicated block, is there any solution to integrate it?
Yes, there are different ways to do that. You can either use our generic integration capabilities, which are available right now in P7 Desktop and will be available soon in pSevenEnterprise. But what essentially we learned recently is that it's not a blocking point. You can create your own block with pSevenEnterprise pretty easily for your CFD tool or whatever tool. And the nice thing is that you can create the block dedicated not for the tool itself, but for your process. This is maybe the most interesting part. So you don't need to wrap, let's say, ANSYS, CFX or whatever in a generic way. You wrap it for your specific problem. And thus you can really remove a lot of parameters, tuning and things. You just set up it for your model, your execution environment, and you're done. And then you have this block in the library, and your domain experts can just use that block. This is something we learned during deployment of pSevenEnterprise in some context.
Clear. Second one, can I run P7 Desktop workflows in pSevenEnterprise?
Oh, yeah, very popular question. Let's say officially not. It's not supported out of the box, but with maybe some shaking and baking, you can do that. But this is not easy task. Let's say. Maybe one day we will create a dedicated block to execute the workflow as a whole without allowing user to go inside of P7 Desktop workflow.
Okay. Question 3, can I use TensorFlow or SageMaker with pSevenEnterprise?
Absolutely. You are free to use any tool inside pSevenEnterprise. You can use it through our Python environment, Python blocks, or you can create your own blocks for your dedicated methods, either without UI user interface or with UI. It depends on you. And we have plenty of examples like that. Okay. Same is true, by the way, for optimization methods. You can use whatever you like. The value of pSevenEnterprise is not methods, it's the collaboration environment, if you want, collaboration automation environment.
Okay. Maybe the last one, do you provide trial licenses for pSevenEnterprise? What is the evaluation process?
Yes, we do provide. It's a bit more complicated compared to P7 Desktop, because desktop application you can just download, install on your laptop and run. With pSevenEnterprise, you need some infrastructure. It's a client-server application. But as soon as you have it, we can provide you with the license. It's more than 1 month. Normally with P7 Desktop, we provide it for one month of trial. With pSevenEnterprise, it's 2 months of trial with extended dedicated support to guide you through the deployment procedure. And yeah, we do provide trainings on top, and we do the follow-up with you. So we are always with you in this process.
Perfect. Thanks for your answers, Sergey. I invite you now to switch promptly to a next session to attend the pSeven Trush from Arena.
Thank you so much.
Bye for now.
Bye.